All right, 2.5, linear and nonlinear relations. Now, with linear and nonlinear relations, we need to look at the data that we're performing on a scatter plot. Data that forms a relatively straight line on a scatter plot indicates that a linear relationship exists between the variables. Now, a line of best fit can model a linear relationship, but is usually a poor model for a nonlinear relationship. Now, you can use a line or curve of best fit to interpolate values within a data set. You can extrapolate values beyond the range of a set of data by extending the line or curve of best fit. Now, so when we're talking about a linear relationship, I'm just going to show you an example of where that could exist. So for example, if we were talking about a linear relationship, I would have a x and y axis and maybe some data that kind of follows along like this. And this data, we would draw a line of best fit. So a line of best fit, because it follows a specific line, you would do it as many points as you can go through. And this relationship indicates a line of best fit. Now, that is a linear relationship between the data. But if we have another table, another scatter plot, let's draw another x and y axis, an independent and dependent axis. Remember, this is the independent, this is the dependent. And I had a set of data, let's say that went like this, okay? That would indicate not a line of best fit, folks, but a curve of best fit. So a curve of best fit. And this curve of best fit would best fit the model. So you wouldn't use a line of best fit in data that look like this, because a curve of best fit is a better representative of that particular data. So this would be a linear relationship, and this would be a nonlinear relationship. Now, to interpolate means that we want to read data on the actual line with the data. If we were to extrapolate, we have to draw extra of that graph, so extra, and read that information. So one more time again, to interpolate, you read inside the given curve that you created. To extrapolate, we have to extend the curve, so make the curve bigger like so, and be able to extrapolate data, maybe determine data over here. So interpolate is to read inside, extrapolate is to draw extra to read outside. All right, so looking at these functions here, you can see that a line of best fit would best represent this data right here, and a curve of best fit would best represent that data right there. So that we have a line of best fit and a curve of best fit. Both one of these, this one, represents a linear relationship. This one represents more of a curve, non-linear relationship. Not a curve relationship, but a non-linear relationship. Now, for this one, a line of best fit does not best match this because there's not enough data to tell what is happening between here and here. We cannot tell if this could have better been served by a nonlinear relationship or a curve of best fit. In this case, there's not enough data to determine that there is a linear relationship between the data. In this example, you can clearly see that the data tends to follow more of a curve for a nonlinear relationship. This line does not go through as many points as possible as would a curve of best fit. And this data over here, if you look very carefully, there's actually no trend in this information. There is absolutely no trend. So it's impossible to say that this line of best fit best represents the data that you find here. In fact, there is no actual, I can't see any relationship because this seems to be scattered everywhere. This one over here seems to follow more of a curve of best fit, and this one here doesn't even have enough data to be able to warrant a line of best fit. So none of these three actually give us a good model to represent a line of best fit. All right, well, that's the end of the video. Have a numerical day.